Good day. We are looking at measurement, and why we care about measurement in Science 8 is we're going to spend a lot of time mastering how to determine the density of material. There are different reasons for getting the density of material, and one of them is to identify an unknown material. Well, in order to know the density of something, we need to know its mass, and we need to know its volume. Once we have those things, we can calculate the density. Measurements will do for mass and volume will either be direct or indirect, so we have to explain what that means. Direct measurement is very nice. It requires only one measurement. We don't have to worry about the mass of the container. We can get the volume directly, these kind of things. Indirect measurement is more complicated. It requires more than one measurement. It may mean we have to worry about the mass of the container. It may mean for an odd-shaped object where we can't measure its volume directly, we'll have to do it in a series of steps. So let's look at measuring mass for solids, direct measurement. You put the object in the scale and record its mass. So we put this on, boom, 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 and you could put a 1 or something in front of there just so it doesn't look like it weighs 0.00 grams or has a mass of 0.0 grams. But for solids, you can simply put them on a scale and you get the mass. But for liquids, we have a problem. Liquids need a container. If we recall the KMT, the particles aren't locked together. If I pour a liquid on a scale, a lot of it's going to slosh off. So that means I first have to put on a container. I have to measure the mass of the container. Then I add the liquid, and now I get the mass of the liquid and the container. Then I subtract the second measurement, the mass of the liquid and container, take away the mass of the container to leave just the mass of the liquid. Now sometimes we can get around that by using the tare, T-A-R-E button or 0 button on a scale. But we always have to be aware, for liquids, when we get the mass, we have to worry about the container. So here it says, okay, let's just set up some numbers. So let's say that's 10.0, and let's just make that 100.0. Now we'd go 100.0 minus 10.0, so the mass of the liquid would be 90.0 grams. That's what I mean. That's something you'll get to have to use unless you can use the 0 button on the scale. Measuring volume. For solids, it's indirect measurement, and it's called displacement. Particularly for odd-shaped solids, we would put in a certain amount of water in a graduated cylinder, and we have to make sure it's not too much, not too little. If we put too much in the solid, it may overflow in the graduated cylinder. If we don't put enough of the water in there, then it may not be enough to cover the solid. So we put the water in first, record its volume, carefully add this odd-shaped object, and record the new volume, and find the difference will give us the volume of the solid. So here's a picture. We take a volume here, whatever that is. Now we add our odd-shaped object, and here's our water. We take a new reading. Taking the bigger number minus the smaller, that difference tells us the volume of this solid object. Because the solid object has pushed water out of the way, it's called the displacement technique. There are other things we can do for measuring volume. We'll show you for rectangular solids, and we'll give you some other formulas as well later. Volume equals length times width times height, stuff you should know from math. We like to measure length, width, and height in centimeters. When we multiply those together, we get centimeters times centimeters times centimeters, which is centimeters cubed. And it turns out by definition, 1 centimeter cubed equals 1 milliliter. If we had 1,000 centimeters cubed, that's 1,000 milliliters, or 1 liter. These are things you have to get used to. Because we have to calculate it, we consider this to be an indirect measurement. Here's an example with numbers. 6 by 15 by 4. So if we go 4 times 15 is 60, 60 times 6, we get 360 centimeters cubed, which is 360 milliliters. For liquids, we like them because liquids will completely fill the bottom of the container. We can just pour them in a graduated cylinder and we get a direct measurement, one step. Just pour it in, take a reading. So it's very easy. And that's it. You see one measurement. So remember or come back and view this again if you're struggling with the difference between direct and indirect measurements. So for a solid, it's direct measurement for mass, indirect measurement for volume. For liquids, it's indirect measurement for mass and direct measurement for volume. Make sure that's under control. You'll be doing a fair number of those. And on the test, you'll actually have to do this as well.